moving on to our next question. Our next question says sine of theta equals negative 0.5. Now, some people don't worry, first of all, about whether it's positive or negative. We do have to consider it. But what I can do is I can take my calculator and find the inverse sine of positive 0.5 and then deal with the negative later. The reason being, remember when I did this here and we saw that all of these had the same number? It's just it depended whether they were positive or negative. So we can do that. We can figure that out and then figure out um, what quadrant it needs to be in. So I think we're going to try that. I've had better luck with students being able to do that part. Okay, so let's find the sine inverse of 0.5. So the sine inverse of 0.5. I know the question says negative, but we know they have the same numeric value, same absolute value. So if I bring up my calculator again and do the sine inverse of 0.5, it comes out to 30 degrees. Okay, it was actually one of the special triangles we could have actually used. And you're saying, oh, please, no, not that. So we have 30 degrees. Now, the only thing is that we know that according to CAST, sine is positive in the first quadrant and second quadrant. We all agree? I know I'm not waiting for you to answer. So it's positive here and here. So that means these terminal arms have to be located in the third and fourth quadrant. So it means that my triangles are located, because remember sine is y, so 0.5 roughly. So what happens is these triangles are created and always to the x-axis, and each one of them has a value of 30 degrees. That's supposed to be straight and it's not. Okay, of 30 degrees. So each one of these triangles in here has a value of 30 degrees. So it's like a mirror image, but in a different, but along the y-axis. So if I folded the y-axis, they would be mirror images of each other. And when I do the coast, they're mirror images of each other. Okay, so how would I get this first theta? Well, the first theta is going to be 180 degrees because from here to here is 180. And then I would add my 30. And this one here would be 360, take away my 30. Okay, so that's how we're going to get our two thetas. So our first theta is going to be 180 degrees plus 30. So we end up with 210 degrees. My second theta is going to be 360 degrees, take away the 30 to give us 3. Okay, fine, you don't like this, move it down, which equals 330 degrees. Okay, so that gives you kind of an idea of what to do when it's negative. Okay, so what happens is you're creating these little right angle triangles that become mirror images in other quadrants, and that's how we determine. We either add or subtract from 180 or we subtract from 360 to find those angles. Now I have one more question for us to look at, and this one is a little bit different, and you'll see why it's different. It says 2 sine squared theta minus theta equals 0. Now we've talked about the squared thing before. Remember that was the same as sine theta and then square it. Okay, so this sine squared theta just means sine theta and all of it squared. Okay, it's just a short form that we do is we write it like this. So how on earth do I solve this one? Because you can see it's not in the same format that the other two were. Now I could, if I take this one here that we just finished doing, I could change its format to make it look different. I could have written for that one, I could have written, come on, pen, go where I want. I could have written as sine theta plus 0.5 equals 0. Okay, and what would you do in that case? Well, you would subtract 0.5 from both sides, right? That's what you would do, and that's how we got sine theta equals negative 0.5. So what do we do in this case? Well, if I subtract or if I add sine theta to both sides, that's still not going to help me a whole lot. But you should notice that there is a common factor. Yes, factoring doesn't disappear even if you're in trigonometry. So we're going to factor out sine theta. That's the first thing we're going to do. So we're going to go sine theta. And when I factor out sine theta out of the first term, I still have a 2. So I have 2 sine theta and then minus 1 equals 0. And you're saying, really? Yes, really. So now what I need to do is I need to separate each factor and set it equal to 0. So sine theta equals 0 and or 2 sine theta equals 0. 2 sine theta minus 1 equals 0. Okay, so what we've created actually is two questions, okay, by doing that. So let's look at the one on the left-hand side first. Sine theta equals 0. Now I could take my calculator and we could do the inverse of 0 and we would end up with 0 degrees. Okay, so I could go sine inverse of 0 equals 0 degrees. Okay, so this is 0 degrees. This is the number 0 because it's a ratio. Now, if I look at my grid here, what that means is it's located right at the initial arm. Okay, so it's right at the initial arm. That's where 0 is. And I lost my pen. So that's 0 degrees. But what other angle is located right there? Well, this is 0, 90, 180, 270. Well, guess what? So's 360. And the question said for angles between 0 and 360. So even though my calculator gave me 0, I have to remember that sine stands for y, and y is 0 in those two places. Now, is y 0 anywhere else? Well, guess what? It's also 0 here. It's also 0 at 180. So when you end up figuring out whether it's sine or cosine, you get numbers like 0, 180 or 90 or 270, you want to check them out because they could be in more than one place. So this one actually has 3 thetas. So how do I make sure that we did it correctly? Well, if I bring up the graphing calculator, I can check to make sure that all 3 of those have a ratio of 0 for sine. So I could go the sine of 360. Oh, it's 0. The sine of 180, it's 0. And obviously the sine of 0 is 0. Okay, so all 3 of those make sine, uh, the inverse of 0 for sine work. Okay, so it could be any 3 of those angles. So that's the first thing that we have to do. So we had to do a little bit more thinking. So our calculator's not going to give us everything anymore. So our first theta for this equation is 0 degrees. Our second theta is 180, and our third one is 360. Okay, so now what we need to do is we still are not finished this question. I'm just going to move this down here. We're not finished this question because I still have the other half of it to work with. Okay, so this one still isn't in the correct format for us to see the ratio. So the first thing we have to do, obviously, is get it so that it is. So I'm going to go back to the blue for that. So the first thing I'm going to do is I'm going to add 1 to both sides. So now I have 2 sine theta equals positive 1. I'm going to divide both sides by 2 so that I have sine theta equals 1/2, or in other words, 0.5. Okay, and notice it is positive. So what that means is we would take our calculator and we would do the sine inverse of 0.5, and we would discover that, because we've already done this one actually, it is located at 30 degrees. There it is there. Now, where is sine positive? Well, sine is positive in the first quadrant and in the second quadrant. So if I just, so we know it's positive here and here. So we have a triangle, and then we also have its mirror image over here, and both of them are 30. So we end up that our third, actually this should have been the number 3, I caught myself. So our fourth theta for this question is going to be 30 degrees, and our final theta is going to be 180 minus the 30 to give us 150. Okay, so this question had 5 thetas. Okay, so it is possible that you could factor and you could solve these things as well. Okay, so as I said, one thing that works really well, take the inverse of the ratio and then deal with the cast part as far as the mirror images of the right angle triangles. Okay, so have some fun. We'll spend a good day at this for sure.